let us get straight into the lesson. And to start us off, you're going to try this first one for us, or for me. I'm going to help you just a little bit. Remember, guys, when we are working with algebra, we are wanting to simplify expressions. There's a couple things that we need to remember. We need to be able to look at what the expression is and know exactly which terms need simplifying. So there are 3 easy steps that we can follow in order to simplify. So the first step is to identify what terms you have in your expression, or identify how many terms you have in your expression. Now, to identify terms, remember, you need to look at the plus and minus signs outside of your brackets or fractions. So that would be that minus sign and that plus sign. What that tells me is that I've got 3 terms here. I've got 5x, oops, daisies. I've got the negative times the bracket 2x minus 7. And then I've got my third term, which is that positive 8x. So once you know what terms you're working with, this can lead you into your second step, where you simplify your individual terms, or each term separately. So I would simplify my first term if I need to, my second term if I need to, my third term if I need to. Remember, sometimes we don't have to simplify all of our terms. In this case, term 1 and term 3 are as simple as they can be. I can't do anything more with that. But in the second term, I definitely can simplify through distribution. Once I've simplified each term, my very last step is to add or subtract any like terms that we have. Sometimes you've got like terms that you can add and subtract, sometimes you don't. You need to check and see whether or not you have any like terms that can further simplify your expression. So what I want you guys to do based on those 3 steps that we have spoken about before, I want you to try and simplify this first expression for me. This is not a hard one by any stretch of the imagination. You guys definitely can do it. So I want you to try and simplify this. Put your answers in the chat. And remember, if you're feeling stuck, follow those 3 steps. Identify your terms, which I've already done for you. Simplify each term. And then double check if you've got any like, so I'm just trying to pull my socks up. It's so cold. And then see if you've got any like terms that you can add or subtract to simplify your expression fully. Right, remember guys, if you're late, that's okay. We understand sometimes things happen. Try this question. Otherwise, remember that you can get the recording online as of tomorrow. Okay, but you're trying this one. I will give you a little hint here in that, remember, in your second term, there's no number in front of this bracket, but there is that negative. So what you actually have here is a -1 that needs to be part of your distribution step. So remember, anytime there is no number in front of either a variable or a bracket, there is that invisible 1. We just don't write it in. Reminder, like terms are terms that have the same variable or group of variables. So for example, xy and xy, or x squared y and x squared y, or whatever, as well as the same exponents. So not only do we need to have the same variable or variables, those variables need to then have the same exponents. Okay, I see some of you can't see the screen. I will reshare it now in a second. Okay, I'm seeing your answers coming through. Keep going. I'm going to give you like 30 more seconds. I like how some of you are just hedging your bets and giving me some options for answers. on that, guys, please remember in grade 8, we're not as strict, or like, I'll be honest, I'm quite strict, but some teachers aren't as strict. Generally, when you are writing an exam, so like at the end of your matric year, what they do is they mark your first answer only. So if you are giving a whole bunch of options for your answers, they're going to mark the first one. So I get wanting to give options just in case you've made a mistake, but bear in mind that sometimes they only mark the first one. Even if the second one is correct and your first one's wrong, sorry, you mark the first one. So try as hard as possible to be confident in yourselves, because you can do it, and be confident then in your answer. Right, would anyone like to raise their hand to explain this one to us? Nice, guys. Okay, Zimmy, help us out here.
Evening, ma'am.
Evening.
So what I did is I brought down the 5x.
Good.
And then I distributed the minus sign and I got negative 2x. And then since 2 negatives makes a positive, I said plus 7.
Excellent.
And then I brought down the 8x.
Good.
And then I did like grouping like terms. I did 5x minus 2x. And then I took 3x plus 8x plus 7. And then I got 11x plus 7.
Excellent. Well done. So guys, just those like terms again, we've got them. So we need to add and subtract them. 5x minus 2x, that's where Zimmy said 3x. 3x plus 8x, it's exactly as Zimmy said, 11x. Then shame, this poor little constant is all by itself, so it's just plus 7. So we identified our terms. I did that for you. You simplified the terms that you could simplify. So in this case, you distributed that negative, and then you added or subtracted your like terms. So if you can follow these 3 steps, you should be able to simplify any expression. And even if you really struggle, follow these 3 steps, you can get method marks. One of my pet peeves is when you just leave an answer blank. Even if you aren't sure, or you're not even sure how to like approach it, try something. At least it gives us something to look for marks. Okay, so try. Follow the 3 steps. Well done, grade 8. Take your screenshots here, and then you're going to have a look at question B. I'm going to help you a little bit, but then you're going to try. Okay, very quickly, we saw that we had 3 terms. We could simplify the second term. I needed to distribute the negative 1 in. So you can see my distribution there in yellow. I took the negative 1, or the negative, I multiplied it with the 2x, giving me minus 2x, and with the negative 7, giving me plus 7. From there, I identified my like terms. So 5x minus 2x plus 8x, all like terms, giving me 11x. And then that plus 7 was by itself. It didn't have an x term, so it wasn't a like term with the rest. And so I could simplify my expression. And again, guys, remember, we have done this both in term 1 and now in this course. So please go and watch the videos if you are feeling a little bit unsure. Alrighty, but if we have a look at B. So again, I'm going to help you a little bit, but you're going to try it. So my first question to you is, and I want to see all your answers in the chat. In the numerator, do you have any like terms? Just yes or no. Are there any like terms in the numerator? Good, well done. Okay, so guys, the reason I'm asking you this is because when we start to deal with fractions, when you've got multiple terms, either in your numerator or your denominator, you want to try and check if you've got like terms, because we know that if I have like terms, I can add or subtract them, and that automatically simplifies my numerator or my denominator. So if I had like terms, that's where I would start. I would first add or subtract my like terms, and then I deal with a fraction. But in this case, unfortunately, I don't. What that means is I'm a bit stuck. I can't add anything there in the numerator. I now need to simplify this thing. So how do I do that? So this is also a form of distribution, but it's distribution with fractions. So we know that if we've got no like terms that we can add or subtract, what we want to do is we want to separate our fractions. Because they're all over the same denominator of 2y, we could separate them and write them as 3 separate fractions, each one with a denominator of 2y. And what that now means is that I have got 3 terms that I can now go and simplify. So if we go back up to these steps, I've identified my terms. I've got 3 fractions. I'm now going to simplify each of them, and then I'm going to double check if I've got like terms. So when you have a fraction where there's lots of things or lots of terms in your numerator and you can't add or subtract any of them, separate your fraction. Then you've got individual fractions that you can work with, and you can now go and simplify. So I want you guys to try this for me. I want you to try and simplify this. Okay, we've written down a definition for like terms so many times, but for the last time, like terms, and I'm probably going to actually write it again anyways, but it doesn't matter. Like terms have the same variable or groups of variables, so like x, y, and xy. And very importantly, this and in the section, the same exponents. So for example, 2x squared y is a like term to negative x squared y because they've got the same variables, x, y, and those variables have the same exponents. Both x's are squared, both y's have a power of 1. So like terms are same variables, same exponents. Sometimes you have them, sometimes you don't, but if you do have them, you need to simplify. Immediately, I feel like I might be a bit stupid here, but 5 minus 1 plus 8. I'm assuming you're talking about the last one. It's not minus 1 because it is minus 2. Please be careful of your distribution there. Right, I will give you a hint here, guys. There should be no fractions in your answer. All of these simplify to non-fraction terms. So that's the hint I'm giving you. Might be helpful, might not be. Hopefully it is. Right, some of you are very close, but I will give you another hint. The last term is not minus y. So if you've got minus y as your last term, it is not minus y. You're close, but not quite. Oh, it's like licorice all sorts here with your answers. Right, 1 more minute, and then I think I'm going to go through this one because I am getting a bit of a mixed bag of answers, which is cool. And this is why we do this, so that we can then correct ourselves. And guys, just a reminder, like terms is only important when we add or subtract. As you can see here, for example, 8y cubed and 2y, they're definitely not like terms. But because we are dividing, we have no issue. So I do not need like terms to divide and multiply. I do need like terms to add or subtract. So in this little bracket here, I'm just going to put add or subtract. That's the only time I care about like terms. Other than that, whatever they are, I can work with them. Alrighty, let's have a look, sweet children. So if we have a look at our first term, so our first term is 8y cubed divided by 2y. Remember to apply SNV, signs, numbers, variables. So if we start with signs, positive divided by positive, positive. Numbers, so 8 divided by 2, that gives me 4. Then I go to the variables. Now remember, we need to apply our exponent laws here. So y cubed divided by y. Now that y does have a power of 1. You can write it there if it's helpful for you, but just really up to you. Our exponent law tells us that when we divide with the same bases, what we need to do is we need to subtract the exponents. So this is going to be y to the power 3 minus 1, giving me y squared. So this simplifies to positive 4y squared. Personally, I don't like the division law of exponents. It's just like I don't like it. So I will say I can cancel 1y in my denominator with 1y in my numerator, leaving me with y squared. If you want to cross cancel, also absolutely fine. It really doesn't matter. So if we now have a look at our second term, so we've got 4y squared divided by 2y. Positive divided by positive is a positive. 4 divided by 2 is 2. And again, we apply our exponent law. Y squared divided by y. I subtract those exponents, and 2 minus 1 is 1. So I've got y, or y to the power 1, whatever you prefer. Then I get to my third term. I'm not too sure why there's hands up. There shouldn't be any hands yet. My third term is negative 2y divided by 2y. Negative divided by positive is a negative. 2 divided by 2 is 1. Technically, they cancel. And the same thing with the y's. If I now go and apply my exponent law and say y divided by y, hopefully we remember that when we divide anything by itself, we get 1. If you apply your exponent law, you're going to subtract 1 minus 1, leaving you with 0, which is, as we hopefully remember, 1. So these actually all cancel, leaving me just with a negative 1. Again, we check if we have like terms. I have no like terms here. I've got a term with y squared, a term with y, and a constant. Those are 3 different types of terms. And so this here, 4y squared minus 2y minus 1, 4y squared plus 2y minus 1 is my final answer. I cannot simplify that further. And so that's where I stop. All right, so guys, hopefully those of you that made silly little mistakes, of which they are silly, that's not, you don't understand, you just made 1 or 2 silly mistakes. Hopefully we've corrected those. Please take a screenshot. And then, Lula, yes, minus 1y is the same as minus y. Not too sure where that's coming from because we don't have any minus 1y's here. But yes, it is the same thing. Lubanzi, yes, anything divided by itself is 1. 20 million divided by 20 million is 1. X cubed divided by x cubed is 1. Negative 7 trillion divided by negative 7 trillion is 1. So anytime we're dividing something by itself, we've got 1. Right, good, grade 8. So while you're screenshotting, if anyone has any questions, now is the time to raise your hand. Otherwise, we're going to have a look at another one. Remember, your screenshotting is 1. Okay, so guys, you need to listen to my words. Anything divided by itself. So 1,000 divided by 1,000 is 1. But 1 divided by 1,000 is not. 1 divided by 1,000 is 0,001. So it has to be something divided by the same thing. That will give you 1. The table, how did we get 4 to the power of 2? I'm assuming you mean 4y to the power of 2. So this term over here, have a look at what I've done. So 8 divided by 2 gave us that 4. And then if we look at the y's, this is what I've done over here. Y cubed divided by y is y squared because we subtract the exponents. So that's where we get 4y squared. The one left, very nicely done. Yes, something to the power of 0 is equal to 1. So if you want to test it out, if you go on your calculator and you can type anything to the power of 0. Let's say you type 4 to the power of 0, gives you 1. Nice. Good connection that you've made there. Well done. 0 divided by 0 is a bit of a funny one. Remember, if we divide anything by 0, we are working with something that's undefined. So that would be undefined. You've taken a tangent though, guys. So screenshots. And I want you to now have a look at question C. I'm not giving you any hints here. I want you to try question C by yourself. No hints. Give it a try. I keep wanting to say my only hint, but I'm not giving you any hints. No hints. So we're just going to sit in silence until I start seeing some answers. So like I say, I'm not giving you any hints. Obviously, guys, remember you are welcome to still ask questions on the chat. Just because I'm not giving you hints doesn't mean you can't ask. So please, by all means, ask. But I'm not giving you any help just yet. I'm liking the answers coming through so far. Remember, we always double check if we've got any like terms. If you don't have like terms, then you don't have like terms. That's also absolutely fine to sometimes end up with no like terms. All right, I'm going to give you 2 more minutes. Remember, guys, oh no, no hints, sorry. Gotta control myself. Right, would anyone like to raise their hand to try and explain this one to us? I really hope I say your name correctly. Gilwe?
Hi, ma'am.
Hi,
How are you, ma'am?
I'm good. How are you?
I'm good, thanks. Ma'am, you start by saying 2x squared y times 3x
Good.
equals to 6x cubed y.
Good.
And then you say 2x squared y times negative 4y squared.
Good.
That will equal to negative 8 squared cubed y.
Okay, sorry, yeah, got you. Now, are these like terms?
No, ma'am.
Good. So guys, very importantly, these are not like terms, and so we can't do anything more with them. That's it. So what I've done here is I've just done the multiplication of the distribution. So the 2x squared y times 3x, 2x squared y times 4y minus 4y squared, sorry, just so that you can see them. But because, yes, they've got both, English. Yes, they both have an x and a y, but the exponents are different. The first term has an x cubed, the second term an x squared. The first term has a y, the second term a y cubed. Those exponents are different, which means these are not like terms, which means that that is my answer. That is it. Excuse me. So when we are distributing, yes, double check if you've got like terms, but sometimes you don't, and that's fine. Right, there was a question of how did I get y cubed? So here we've got a y times y squared. Remember, my multiplication law tells me that I add the exponents, so 1 plus 2, which gives me 3. Remember, multiplication is telling me how many times I'm multiplying a value. So I've got 1y multiplied by 2 y's. In total, I am multiplying 3 y's. That is why my exponent for y is y to the power 3. I've got 3 y's that I'm multiplying together. That is what multiplication and essentially exponents tells me, how many times I'm multiplying something. Right, very nicely done, grade 8. Sure, my brain. Take your screenshots. If you have questions, you can raise your hand. Otherwise, I think it is very much time for a brain break. You've very much deserved it. You guys are on point tonight. On fire. Stretch, no sleeping. Although, to be fair, I could have had a nap at 2 o'clock today. Right, sweet peas. Brain break time. So remember, we sort of back to our usual. We are looking for in the brain break. So just so we're all clear. I want the value of this last equation down here. You need to find the value of the duck, the mouse, and the pigs in order to work that out. So give it a try. The first person who puts the right answer on the chat is going to explain it to us. There was a question of, can we do revision of exponent laws? Yes, Lawandle, we actually are going to do that in our next course when we are revising term 1 and term 2 work. We're going to revise exponent laws. Remember, the videos are online, so you can go back and watch those videos, but we are going to revise it. Okay, I've just made it a bit smaller so that you can see the joke if you want. I'm going to make it bigger now because remember, guys, we need to be careful of where we've got 1 pig, 2 pigs, 2 ducks, 2 mice, whatever the case is. So just be careful. Oh, I'm sorry, you've got 2 exams, but you'll be fine. At least it's English and I'll own. Hopefully not too bad. Unfortunately, as you start to write more and more exams, you often have 2 exams in a day. So sucks, but you can do it.
Yeah, you guys can do it. And all the best. Let's see who's gonna get it right. The first person to get it right is the winner of our brain break. Did you guys see the joke? I laughed in my heart. I was laughing. And so I can imagine you guys. The answer is not 45. Keep trying. Remember, we want the final answer. So
So yeah, guys.
final answer, my people.
Oh. My marking is taking it out of me. We've had so many maths exams the last few days. It's just crazy. The joke is not currently on the screen just because I've made the brain break a bit bigger. I will make it a bit smaller in a second or two once we've gone through it, so you can see the joke if you would like. I just made it the screen bigger so that we can clearly see where we've got 1 mice, 2 mice, pigs, and all the rest of it. But I will make it smaller just now once we've gone through. Lwandle, yay! Well done.
And one day, our brain break winner. That is the Snapchat lady teaches that.
Is the
I'm not
Snapchat
sure what does
lady
that.
this thing? This thing. If
I'm
you're
also
talking
not
about
sure.
this lady, then yes, that is my avatar. She looks better than I do. So
Wait, who got it first again? Someone got it.
Lwandle.
Lwandle, we need you to come explain, Lwandle. You got the correct answer, but you must explain. You must explain how you got it. I see Renelwe also got it. Here is Lwandle.
Hey, tell us.
Evening, ma'am.
Hello.
So, since for the second one, I just kept juggling around numbers, right? So I knew 4 plus 4 times 3 equals 12. So I just said 4 plus 4 plus 4. And then for the second one, I just put the 4 down where the duck was. And then I said, I started from 7. I put it in my calculator. I said 7 plus 7 times 4 until I got to 9, right?
Good.
I said 9 plus 9 times 4, which gave me 45. So then, since I saw that there were 2 rats, I said 18. So 9 plus 9 equals 18, which I knew that. And then for the pigs, I did the same process as I did with the rats. I just kept juggling around numbers. I started from 10, and then I got to 16. So I said 16 plus 18 times 16 gave me 304. So then I saw that there were 2 pigs on the last one, plus 1 rat, which is 9, plus times multiplied by 2 ducks, which is 8. So I then said 9 times 8, which gave me 72. Then I said plus 16, which gave me 88.
Excellent. Well done. And guys, very important in English. Very importantly, there was Lwandle's last working out there. We do multiplication first. Okay. Multiplication BODMAS comes first. So we needed to do the 9 times 8 first and then the plus 16. Very nicely explained, Lwandle. Thank you. Well done. I know you've already muted yourself, but thank you. We appreciate you. Right, so guys, that's how you do the brain break. I also like Lwandle's thought process, especially in step 2 and 3, and that we didn't know exactly what the mice or the rats or the pigs needed to be. So let's just play around with some numbers. We know the operations that we need to have. Let's play around and see what happens. Just because we see something, we're automatically like, oh, I don't know, I don't want to do it. That unfortunately isn't going to work. Try. And that's what I was saying earlier. Play around, see what you get. If you've spent 2 minutes on it and you still can't get it, move on and come back, but try. All right, for those of you who wanted the joke, there it is. Which subject, no, let me move everything so I'm not talking rubbish. Which subject does Al excel at? Algebra. And you are currently doing algebra. On the nose. Right, guys, let us do some algebra. So I'm going to put 2 up. Let's see how you do. So for the first one, what I first want to point out is that we need to know where our terms are. Remember, that was our first step. So this minus sign, the one outside the bracket, is going to separate my terms. Whoopsie daisies. So here is term 1. Here is, here is term 2. You need to know which terms are which, because now you want to simplify your terms. This first term can't be simplified. It's going to stay there, but we need to simplify the second term. In question E, remember a root or square root, cube root, whatever root acts as a bracket. So first see if you can simplify what's happening underneath the square root before you actually apply the square root. So those are my 2 hints for these 2 questions. I'm going to give you, let's say, 5-ish minutes. See how you go. Put your answers in the chat. Remember, your answers need to be numbered D and E, so that I know which is which. But give it a try. Fatima, no, unfortunately, I don't make up these jokes. I do have some jokes that my kids at school that I teach at have made up, but they're all based on trig, which unfortunately we don't do. But maybe if I ever teach you in grade 10, grade 11, we'll have some trig jokes. But no, these are, I can't claim them to be my own jokes. Manolo, well done. Screenshots. Yeah, I've got a joke board, a joke wall in my classroom where my jokes go. Right, guys, but we're trying these 2. Let's see. D and E, I want those answers in the chat. I can't tell you why there's a weird E just underneath D, but let's just ignore it. You know, pretend it's not there. It's not a problem. There we go. Oh, sorry, I've got such a cough. So remember, guys, first one, simplify your second term first, then double check for like terms. Question E, first see if you can simplify or deal with what is underneath that square root before you start stressing about the square root. Remember, a square root or a cube root or any root acts as a bracket. BODMAS tells us to deal with the brackets first. So that's what we try and do first. Keep your answers coming. You're doing really nicely, guys. Yo, guys, you're doing so well tonight. I'm so proud of you. Clearly, we've all been studying really hard for our maths exam. Remember, guys, when you're multiplying with exponents, you need to apply your exponent laws. That's very important. And remember, exponent laws tell you that if you are multiplying with the same variable, you add the exponents. Remember as well, when you are multiplying, you can use SNV to hopefully make you or help you multiply correctly. SNV also works with division, but we don't have division here, so we're not going to stress about it, but it does work with division as well. Keep those answers coming. You guys are doing really nicely. Malele, thank you for telling us which one it was. Guys, remember, label your answers. As much as I know what the answer should be, I do want to be able to see what you've done for each question. And remember, when we go through the answers, you need to be making corrections if necessary. Obviously, if you've got it right, you can give yourself a pat on the back. I'm going to give you another minute or two to finish those two off. I know lots of people have only started with E now, which is cool. So just remember everything we've spoken about, your exponent laws, like terms, using SNV to multiply, all of these things that we've spoken about the whole year, we need to use now. Okay, one more minute. If you're done, get ready to mark. Close, Triple. You're getting there, guys. Square roots and cube roots always throw us off a little bit, which I completely understand. We sometimes don't always expect to see them, but we do need to know them. Right, my sweet children, would anyone like to raise their hand to give me an answer for either of these two? We can start with D or E. It doesn't really matter. I don't particularly care. Nice, guys. Okay, Chantal, would you like to do D for us? There should be a pop-up to unmute yourself. Whoops, there we go. Okay.
Ma'am, so I started with saying 7 x to the power of 3
Yeah.
minus 5x to the power of oh no, ma'am, sorry, ma'am, I said 5x times x to the power of 2 minus y, so I got my like 5x to the power of 3 minus 1.
Good. Okay, so guys, remember we're distributing here. So we've got minus 5x times x squared, which gives us that minus 5x cubed. And then we still need to distribute that to the minus y. So minus 5x times minus y. Negative times a negative, positive 5xy. Okay, so Chantal, carry on.
And ma'am, I said 5x to the power of 3 minus 5x to the power of 3 is equals to 2x to the power of 3.
Good. Okay, so guys, the 7x cubed and the minus 5x cubed are like terms. So we need to subtract them. And then we've just got that plus 5xy. Hey, Chantal?
Yes, ma'am. And
Good.
then plus 5xy, because it's not a like term, to 5x to the power of 3.
Excellent. Well done. So guys, this 5xy, as Chantal has just said, it is not a like term to the x cubed terms. So that's it. I stop there, can't do anything more. I've got no more like terms to add or subtract. And so I'm finished. Right, and Nkululeko, do you want to do E for us? Excuse me.
Hi, ma'am.
Hi. Are you still there? Nkululeko, are you going to do E for us?
Yes, ma'am.
Okay, I'm ready.
So, ma'am, I started with the roots, ma'am. So I said 4y to the power of 3 multiplied by y. So, so ma'am, 4 multiplied by 1, that gave me 4. So, ma'am, for the exponents rule, we say if you multiply, we say y to the power of 3 plus 1.
Good.
That gave me 4y to the power of 4.
Excellent. Well done. Okay. Then?
So, because they are not like 10, ma'am, you're going to say y to the power of 2 plus 4y to the power of 4.
And what about the square root?
H,
Okay, so you've done really nice in Nkululeko. This is a hard one, so well done. So guys, firstly, what I want to just point out is Nkululeko said right now we don't have like terms, and that is true. So we need to double check. Have I simplified my terms fully? So y squared is y squared. I can't do anything with that. But the square root of 4y squared, what we need to remember is that anytime we have got a single term underneath the root, that root can be separated. So I can work out the square root of 4, and I can work out the square root of y to the power of 4. Now, the square root of 4 is nice and easy. We know that's 2. 2 times 2 is 4. But when we get to the square root of a variable, there's a bunch of different tricks we can use. But basically, we are asking ourselves, what two identical values do I times together to get y to the power of 4? And if we just break that down, that would be y squared times y squared. They're identical, as Nkululeko said, and as Chantal said, when we go and multiply with variables, we add the exponent. So 2 plus 2 is 4. And so the square root of y to the power of 4 is y squared. Another little trick that you can use, because I know sometimes it isn't always the easiest thing to think of that on the spot, is that when we root something, we will take the exponent and we divide it by what the root is. So the root here is squared. So we divide it by 2. 4 divided by 2 is 2. So what that means is that this second term of square root 4y squared simplifies to 2y squared. And now this goes back to what Nkululeko said. We check if we've got like terms. We do have like terms here. I can see that I've got a y squared and a y squared. So I can add these two terms together to simplify further, giving me my final simplified answer of 3y squared. Remember, when we add or subtract like terms, I can't remember if I've written this down, so I'm just going to do it again. When we add or subtract, try that again, add or subtract like terms, we do not change the exponent. So the exponents stay exactly the same. And the reason for that is, guys, you're adding and subtracting. You can't add apples and apples squared. You want apples and apples. If you add in y squareds and y squareds, you end up with y squareds. We don't change anything about the variable. Right, but very, very nicely done today, grade 8. You really did very nicely. Take your screenshot of this. You'll also see that the poll is up. Please do the poll. And then remember, we'll see you on Wednesday where we will do a little bit more revision of this. And a reminder, I think I want to say it was Lwandle, but I can't remember. We are going to revise all of this again when we do term 1 and term 2 revision. I know in Lwandle, unfortunately, we're at Monday, but the second we hit Wednesday, the week goes so quickly. So Let's not wish it all away too fast. Oh, sorry, guys. You know. Right, we're only at 88% on this poll. Let's go. Ah, how did we go down to 87%? Aye, aye, aye. So, Noviso?
Morning, ma'am.
Hi.
Ma'am, I would like to get an explanation of how did we get 3y2 instead of 2. I thought the answer was supposed to be 2 to y to the power 2.
Okay, so remember, we still had this y squared term from the start. I didn't do anything with it because I couldn't simplify it, but I still had
Okay.
it. The y squared and the 2y squared are like terms. Remember,
Yes,
there's a
ma'am.
1 in front of that y squared. So if you add 1 plus 2, that gives me the 3y squared.
Oh, yes, ma'am. I
Okay, good.
understand.
Well done. Well done. Okay, just there were a couple questions in the channels, yeah. If you haven't done geometry at school, then no, it won't be in your paper too, because your teacher set your papers. They obviously won't put in something that you haven't done. It will be in at the end of the year. Bunzi, there are classes during the holidays. I think there will be some communication about that moving forward. When are we going to do revision? We start revision next week, Monday, of term 1 and term 2 work, and then holidays, and then we start obviously term 3 stuff. Well done, guys. Poll at 100%. You guys were amazing tonight. You should be very proud of your work ethic tonight. So
Yes.
well done.
To everybody, and good night. We'll
Right, bye,
see
sweet children. See you on
you Wednesday.